Today we are doing lesson 4.1, writing and graphing inequalities. Today's I can statements, I can graph inequalities, and I can write inequalities for real life problems. So for our first type of problem, we're just going to practice writing an inequality. So an inequality is a mathematical sentence that compares expressions. It contains the symbols less than, greater than, less than and equal to, or greater than or equal to. And then a solution of an inequality is a value that makes the inequality true. So down here at the bottom, we have some inequality symbols. This first symbol here is less than. Another key word for that is fewer than. Some people think of less than as kind of looking like a sloppy L, less than. Greater than, another key word is more than. The symbol is less than or equal to. Some key phrases for that are at most or no more than. And then for our last one, greater than or equal to, at least or no less than. So for this first type of problem, they're going to write a word sentence, and we have to write it as an inequality. So a number x is at most negative 10. So a number x means writing x, at most means less than or equal to, and then negative 10. For number 2, 4 times the number b is greater than negative 4 and 7/10. So 4 times b just means 4b is greater than negative 4 and 7/10. So let's go ahead and practice these. Write the word sentence as an inequality. When a number y is no more than negative 8. Our inequality statement here, no more than. That means less than or equal to. If we go back here, no more than, less than or equal to. All right. Number 2, number b minus 4 2/10 is less than, here's your key phrase, less than negative 7.5. b minus 4 2/10, less than looks like a sloppy L, less than negative 7.5. And then the last one, a number t multiplied by negative 4 is at least, there's our inequality sign, at least negative 2/5. So t multiplied by negative 4 is negative 4t, at least, so greater than or equal to, negative 2/5. All right, our last one down here, you have at most 25 games on your smartphone. Write an inequality that represents this situation. At most 25 means the amount of games is greater than or equal to 25. And I'm just going to use G for games. So the number of games is greater than or equal to 25 games. Anytime we have a story problem situation, remember, we need an label on our answer. All right, now let's take a look at how to graph an inequality. So a graph of an inequality shows all the solutions of an inequality on a number line. An open circle like this one is used when a number is not a solution. A closed circle like this is used when a number is a solution. And then the arrow that goes to the left or the right shows the graph continues in that direction. So we have to shade in everything that's a possible solution. So for this one down here, it says graph y is greater than negative 3. You would use an open circle because negative 3 is not a solution. Negative 3 is not greater than negative 3. However, if we pick one of these other numbers, like say 0, and we put it in for y, it would be true. 0 is greater than negative 3. 2 is greater than negative 3. Those numbers are all solutions, so we shade right on top of that line there. That's because all of these numbers are greater than negative 3. All right, let's go ahead and practice doing these. Now, when you do your number lines, our number lines really only need to have 3 numbers on there. If you want to do more, that's fine, but at the very minimum, you need to have your number in the middle. So on this one, the number is 2 5/10. and then one value that's less and one value that's greater, and they all need to be equally spaced apart. So when I have decimals like this with one decimal place, I usually go up by tenths. 2 and 4 tenths, 2 and 5 tenths, 2 and 6 tenths. As the number line goes to the right side, those are where the bigger numbers are. Smaller numbers are to the left side. D is less than or equal to, so it could equal 2.5. So we're going to put a closed circle here. And then less than or equal to. So less than 2 and 4 tenths, if I put it in to that inequality, would be a possible solution, because 2 and 4 tenths is less than or equal to 2.5. Now a trick here for graphing, if your variable comes first, the inequality points the same way you would graph. So here it's pointing to the left, we go to the left. That trick only works though when the variable comes first. The variable comes second, like in this last one, it will not point the way that you need to shade. All right, let's look at this next one. Y is greater than -1. I'm going to do it over here where I have a little more space. -1 is going to go in the middle. 1 less is -2. Remember, negative numbers, the order on the number line is the opposite of how it would be if it was positive. So -2, -1, 0. Going to the right, those are the larger values. Okay, it cannot equal -1, so I'm going to do an open circle. And then it's greater than -1. So if I put in 0, that would be true. 0 is greater than -1. So I'm shading to the right here. And on this one, since my variable came first, my inequality sign does point the same way my arrow is where I'm shading, pointing the same way. All right, number 3, 53 is greater than or equal to P. Some people, when they're graphing, prefer to have that variable first so that they can use that arrow points the correct way, that your shading trick doesn't work if the variable comes second. However, if I flip-flop these, I need to flip-flop the sign as well. When you first learn about inequalities, you learn the alligator eats the bigger number. On this one, it's the 53. The alligator wants to eat the 53. So if I change the P to come first, the alligator still wants to eat the 53. 53 is still the larger number. So we change signs, so our inequality sign flip-flop too. P is less than or equal to 53. 52. 53 and 54 is a closed circle because 53 is a possible solution. Shaded to the left. Either way you look at that inequality, if I take 52 and put it in, it would be true. 53 is greater than or equal to 52, or 52 is less than or equal to 53. So yes, I've shaded the correct way. Word problem, each day at least 75, here's my inequality words, at least 75 students buy milk from the cafeteria. Write and graph an inequality that represents the situation. All right, let's see. I'm going to say M for milk. At least means greater than or equal to 75 students. All right, so now I need to graph. I'm going to do it down here. 74, 75, 76. All right, at least means it could equal 75, or it could be more than that. So I'm going to shade to the right. That's where the larger numbers are. If I put in if I put in 76, that would be true. 76 is greater than or equal to 75. All right, so for our next type of problem, we're looking at if something is a solution of the inequality. So to do that, we are taking whatever the value is and putting it into the inequality and simplifying it to see if it's true or not. So let's take a look at this first one. Instead of the y, I'm just going to put in a -2 minus 5 is greater than or equal to negative 6. So I took this negative 2 and I put it in where the y is. Okay, negative 2 minus 5, if I do boom, boom, it's like negative 2 plus negative 5. Same signs, find the sum, that's negative 7. Negative 7 is greater than or equal to negative 6. No, that is not true. Negative 7 is less than negative 6. It's not greater than negative 6. So this one's going to be a no. You have to show your answer or work for your answer. You can't just write no. But no, that one is not a solution. Let's check our next one. So again, we're going to put in negative 2 for the y. Negative 5.5 y means negative 5.5 times y. And on this one now, y is negative 2, is less than 14. Since I have decimal multiplication, I'm going to bring that over to the side here. I'm going to pretend it's like 55 times 2. 2 times 5 is 10. 2 times 5 is 10 plus 1 is 11. 1 decimal in the problem, 1 decimal in the answer. And then these were both negatives. I should have written them over here when I wrote the problem. Same sign, answer is positive. So I have a positive 11 is less than 14. That is true. 11 is less than 14. So yes, negative 2 is the solution for that inequality. All right, go ahead and pause the video and try these next 3 on your own. Okay, let's check our answers. So for number 1, I am putting in negative 5 where x is. I'm recapping the rest of the inequality. Negative 5 plus 12 is greater than 7. Now I'm going to simplify. Negative 5 plus 12 is 7. 7 is greater than 7. No, 7 is equal to 7, but 7 is not greater than 7. All right, let's try number 2. 1 minus 2 times negative 5 is less than or equal to negative 9. I'm going to go ahead and do a boom, boom on my minus sign there. All right, now I'm going to use order of operations, so we multiply first. Negative 2 times negative 5 is a positive 10. So now I have 1 plus 10 is less than or equal to negative 9. 1 plus 10 is 11. 11 is less than or equal to negative 9. Nope, that's not true. And then number 3, n divided by 2 and 5/10 is greater than or equal to negative 3. To cancel out the divided by 2, oh, I'm sorry, we're not canceling these out yet. We are substituting. We're not solving it, we're substituting. What was I thinking? Okay, negative 5 divided by 2.5 is greater than or equal to negative 3. All right, so let's see. If I have 5 divided by 2.5, it's like moving that decimal one place over, placeholder 0 here. So now it's really like negative 50 divided by 25. 25 goes into 50 2 times. 2 times 25 is 50. All right, and then I have different signs, so my answer is going to be a negative. Negative 2 is greater than or equal to negative 3. Yes, that is true. Negative 2 is closer to 0 if you're comparing two negatives. The one that's closer to 0 has a greater value. All right, go ahead and pause the video again and try these next 4. All right, let's check our answers. So for number 4, x is less than negative 1. You need at least 3 numbers on your number line. Negative 2, negative 1. Whoops, I said negative 1 and I wrote 0. Let's try that again. Negative 2, negative 1, 0. Open circle on the negative 1. Shaded over to the left. If your variable comes first, the arrow points the way you're shading. Same thing. Only if the variable comes first. All right, z is greater than or equal to 4. Gotta set up that number line. 3, 4, 5. Close circle, it can equal 4. Shade to the left. These are the numbers that are greater than 4. We're shading in our possible solutions. If I put in 5, it would be true. 5 is greater than or equal to 4. All right, let's take a look at this next one. S is less than or equal to 1 4/10. 1 3/10, 1 4/10, 1 5/10. You need to make sure those intervals are even between your numbers. Okay, closed circle here could be equal to 1 4/10, and then shaded to the left. If I took 1 3/10 and put it into the inequality, it would be true. 1 3/10 is less than or equal to 1 4/10. All right, my last one here, I need to graph it. If it helps you graph, you can flip-flop it. T is greater than -1/2. Remember, our arrow pointing the way we're shading only works if the variable comes first. Alligator's eating the bigger number. T is the bigger number. So when you flip-flop, that sign has to go too. You don't have to flip-flop it. I'm just showing you that strategy because a lot of people like to use it when they're graphing. 1 1/2. I'm sorry, -1, -1/2, 0. All right, cannot be equal to 1/2, -1/2. So I'm going to have an open circle here. T is greater than means I'm shading to the right. All right. Last one. To decide whether a number is a solution of an inequality, you go ahead and write down a solution. Pause the video, write down your solution. Okay, so let's go ahead and check our answer. So to decide whether a number is a solution of the inequality, that's like these problems right here. What do? You substitute the number into the inequality. And solve to see if it's true.